So, let me now revisit and look at what we have been talking about earlier and why we started looking at this positive real transfer functions and so on. So, the reason why we started looking at these positive real transfer functions is, first of all, there was this Eisenmann's conjecture, and from the Eisenmann conjecture, a certain guess was taken that, if you have a nonlinearity in some certain sector and you have a feedback connection of that nonlinearity with a linear system, then if that linear system with those particular gains gives you a stable closed loop system, then the linear system with the nonlinearity in that loop will give you a stable system. And then we also saw that counter examples were given, so Eisenmann's conjecture is not correct. Now, after that we came into this passive systems and what these passive systems are, and we have a lot of results with respect to passive systems. Now, the important thing about passive systems is that if you interconnect two passive systems, I mean if you have a feedback connection of two passive systems, then the resulting system is also passive. And this makes things very good, because what one is really saying is, if you start off with some system which is passive and you have another system which is passive and you interconnect the two, the new system that you get, which is the interconnection of the two systems, is also passive. And this, I mean, especially if you think about this passivity in terms of the energy, that means the passive system is something where the total amount of energy supplied is either dissipated or it goes to increase the stored energy, then this seems very natural. But what we will now do is, we will formally show that when you interconnect two passive systems, the resulting system turns out to be passive. As a result, it turns out that this concept of passivity is something that goes a long way in answering the question raised by Eisenmann, and in fact providing an answer which is similar to what Eisenmann guessed. Okay, so let me begin by first talking about the lemma or the theorem. Okay, might as well call it a theorem. Interconnection of two passive systems is passive. Okay. Okay. So what do I mean by this interconnection? Okay. So let me assume this is system 1. Let me call it G1. So let me call the input U1 and the output Y1. And let me have a second system G2. So, okay, input, you see, when you are talking about input and output, one needs to probably draw an arrow so that it is clear what is the input and what is the output. So, U1 is the input and Y1 is the output. And let us have another system G2, and this system has U2 as the input and Y2 as the output. Now, G1 is passive. What does it mean to say G1 is passive? Well, one thing that from all the discussion that we had about passivity is that U1 Y1, let me say U1 transpose. So, rather than think of it as single input, single output, I could think of it as multi input, multi output. So, I am saying U1 transpose Y1 is greater than equal to V1 dot, where this V1 is the storage function of the first system. Okay, so we had said that for the passive systems, the product of the input and the output is greater than or equal to the rate of change of the storage function. So V1 is like the amount of energy stored in G1 roughly, and so U1 transpose Y1 is like the amount of energy supplied, and the energy supplied is greater than or equal to the rate of change, or the power supplied is greater than or equal to the rate of change of the stored energy in the first system. Now, this one being passive, essentially you have a similar statement, U transpose Y2 must be greater than or equal to V2 dot. Yeah, and this V2 dot is the storage function of the second transfer function. Okay. Now, let us look at what we mean by interconnection. So, let us interconnect it in the following way. So, I put in this thing, and I will assume that there is some input E1 coming into the net system, and maybe I subtract this. So, what this essentially tells me is that U1 equal to E1 minus Y2, and I do a same kind of thing here. So, there is some input here, which let me call it E2. Now, of this system, this is the interconnected system, and in this interconnected system, I can think of the vector E1, E2, the vector E1, E2 as being the set of inputs. Okay. And I can continue to think of Y1 and Y2 as the set of outputs. So, then input times output is essentially E1 Y1 plus E2 Y2. Now, for E1, if I substitute U1 plus Y2, so I get U1 plus Y2 times Y1 plus, now I have not written the equation for this. Here, this I would continue to call it positive. So, what I have is U2 is equal to E2 plus Y1. Okay. So, this E1 Y1 plus E2 Y2 is equal to U1 plus Y2 times Y1, and for E2 I can substitute E2 is U2 minus Y1. So, U2 minus Y1 times Y2. Of course, there are these transposes, but that really does not matter. Now, you see you have a Y2 transpose Y1 and you have a Y1 transpose Y2, but with negative signs. So, they sort of cancel. So, what you are left with is U1 transpose Y1 plus U2 transpose Y2, which from these two inequalities you know is greater than or equal to V1 dot plus V2 dot. Now, what does this mean? This means that if you take this E1 and E2 as the inputs for the interconnected system and the Y1 and Y2 as the output, so for this interconnected system, when you look at the inputs multiplying the outputs, this is greater than or equal to the rate of change of a storage function, which is in fact the sum of the storage functions of the first one and the second one. So, in physical systems, if this was a physical system and it had some elements which stored energy, and this is another system which has some elements which is storing energy, then the complete storage function is the sum of this storage function plus this storage function. Yeah. So, now this is an extremely powerful sort of result. And therefore, I mean what we can say is if you have two systems which are passive and you interconnect it, then the interconnected system continues to be passive. Now, if I mean, how this this theorem becomes really powerful is by the following means. You see, suppose you think of this G1, this system G1, as a linear system which is passive. G2 is some system which is, let's say, a non-linear system, but you can sort of by some means show that this is passive. Then if you interconnect these two, then the interconnected system is also passive. So, if this was a nonlinear system and you manage to find some storage function for this nonlinear system, then in some sense you have found a storage function for the complete nonlinear system. Now, if you are talking about, for example, Lyapunov theory, and so you don't think of these inputs. Earlier we had discussed how, given a general nonlinear equation, you can split it up into a linear part and a nonlinear part. And now, if you can show that this linear part is passive and this nonlinear part is passive independently, and for this nonlinear part you can find some storage function. For the linear part, of course, we already have the positive real lemma and the Kalman-Yakubovich-Popov lemma, by which you can find storage function. Then the sum of these two storage functions act like the storage function for the net system, but with zero input, the sum of the two storage functions would act like the Lyapunov function, and therefore, this is in fact a way to construct a Lyapunov function for that particular system.